Good day everyone, welcome to another video lesson and I hope you will enjoy watching and learning this. So we are now going to have the types of probability. We have the theoretical probability and experimental probability. So our lesson objectives for today are the following. Define the probability of an event. Differentiate between a theoretical probability and experimental probability. And solve probability problems. Okay? So let's have the first objective. Define the probability of an event. Okay? So let's have the definition of event. It is a subset of sample space in a particular experiment. Okay? Sorry sa aso ng kapitbahay. So we have the experiment, a fair die is rolled. The event can be the following. Getting a 4, getting an odd number, getting a number less than 3. Okay? So how are we going to solve for the probability? We are going to use the formula probability of an event or P of E is equal to the number of favorable outcomes and the number of possible outcomes. So we have N of E divided by N of S. Okay, so how are we going to use this? So let's answer the following questions. A fair die is rolled. What is the probability of getting a 4? For us to solve this, let us have first the N of S, wherein that is the number of sample space or the number of possible outcomes. So we have in all, we have 6 because we all know that a pair die is numbered from numbers 1 to 6. Okay, so what is the probability of getting a 4? Out of 6, we have 1. Okay, because we only have one piece of number 4 in a numbered cube or a fair die. Okay, so if you can reduce this to lowest term, so you have to reduce, but since it is not, so our answer is 1 over 6. Next, getting an odd number. So out of 6 possible outcomes, we have 3. So what are those? We have 1, 3, and 5. That's why we have 3 out of 6. And since we can reduce this to lowest term, so we have to reduce, and that is correct, 1/2. Next, getting a number less than 3. So out of 6, what are those numbers or how many are those numbers less than 3? That's correct. We have 2. Okay? Why is it 2? Number less than 3 are those numbers 1 and 2. You will not include 3 because the question is number less than 3. So you only have 1 and 2. So that's why you have 2 out of 6. Reduce this to lowest term, that is 1/3. And again, from our previous videos, we all know that probability can be expressed as fraction, decimal, or percent. So we have here 1 over 6 is 0.1667 or 16.67%. 1/2 is 0.5 or 50%. And 1/3 is 0.333 or 33.33%. Okay, so question? Okay, next. Another example. A circle is divided into 12 parts or 12 equal parts to form a spinner. It is numbered as shown on the right. Okay, so we have here the spinner. So when the pointer is spun, what is the probability that will stop at 7? Okay, so we have to take note that the arrowhead will not stop on the line. Okay, so for us to answer the probability that will stop at 7, let us have first the sample space. So we all know that the sample space here is 12. As you have seen, we have numbers 1 to 12. And the spinner or the circle is divided into 12 equal parts. So that's why the sample space is 12. Okay? And we have seen, okay, obviously, we only have one piece of number 7 here. So that's why the probability that will stop at 7 is, yes, 1 out of 12. Next, what is the probability that will stop at a prime number? So out of 12, we have, okay, 5 prime numbers. What are those? We have 2, 3, 5, 7, and 11. Okay, can you reduce this to lowest term? No, so that's why you have 5 out of 12. Next, a number between 5 and 10. What are those? Okay, how many are those? Okay, so out of 12, we have 4. Okay, what are those? We only have 6, 7, 8, and 9. You will not include 5 and 10 because the question is between 5 and 10. So, you will not include 5 and 10. And 4 over 12 can be reduced to lowest term, and that is 1 over 3. Next, what is the probability that will stop at negative number? So, out of 12, we have, yes, 0. So, we haven't seen any negative number here. So, that's why it is 0 out of 12. Okay? So, again, these answers can be expressed in decimal or percent. So, we have here the following. So, I will just flash the answers. So, we have here the decimal answer and the percent form. Okay, question? Okay, next. Let us have the 4 probability rules. So let us have letter A, or the first one. The probability of an event E is a value from 0 to 1, which is, I have already discussed that before on your previous video. So again, from 0 to 1 only. Next, we have the probability of an event that cannot happen is 0. Okay? So if it is impossible to happen, so the probability is 0. Okay? Next, let us have letter C. The probability of an event that is sure to happen is equal to 1. Okay? Next, letter D. The sum of the probabilities of all the outcomes in the sample space is 1. Okay? So we have to take note of these 4 probability rules. Okay? So next, let's have the second objective. Differentiate between a theoretical probability and experimental probability. Okay? So let's have the theoretical probability. So it is the likeliness of an event happening based on all the possible outcomes. It is the ratio for the probability of an event P occurring as P event. So it is also the number of favorable outcomes divided by the number of possible outcomes. So just like what we have before. Theoretical probability is determined by noting all the possible outcomes theoretically and determining how likely the given outcome is. Okay? So again, we have here the formula of probability or theoretical probability. The number of favorable outcomes of event divided by the number of possible outcomes. While we are going to have the experimental probability, it is the ratio of the number of times an event occurs to the total number of trials or times the activity is performed. It refers to the probability of an event occurring when an experiment was conducted. The probability of an event is being determined through an actual experiment. While in theoretical, as we have before, you can have the probability even without doing the activity or the experiment. While in this probability experimental, you have to do the experiment in actual. Okay? So, let's have the difference. Sorry. So, let's have the different examples of theoretical probability. Okay? So, we have a coin is flipped. So, the probability of getting the head is 1/2 and the probability of getting a tail is 1/2. If we have the experimental probability, we have a coin is flipped 30 times and the student records the outcome of each flip. So we have here the record of the student on the number of times of the number of heads and number of tails. Okay? So we have here from the given result, the probability of head is 12 out of 30 or 2 over 5 or in decimal or percent. The probability of getting the tail is 18 out of 30. So we have here 3 over 5 or 0.6 and 60%. So your answer can be in fraction, decimal, or percent. So which one do you prefer is acceptable. Next, Let's have a die was rolled. The probability of getting 5 is 1 out of 6. The probability of getting 4 is 1 out of 6. Okay, so I have here again the decimal and the percent form. If we have the experimental probability, okay, so we also have here the probability of having even. So we have 3 out of 6 because we have 2, 4, and 6. So reduced to lowest term is 1/2. Okay? Next, or 0.5 or 50%. In experimental probability, we have a die was rolled 100 times. 5 appears 50 times and 4 appeared 10 times. Find the probability of getting 5 and also the probability of getting 4. Okay? So we have here the probability of 5 is 50 out of 100 or okay, 1/2 or 0.5 or 50%. And probability of 4 is 10 out of 100 or we have 1 out of 10 or 0.1 or 10%. Okay, question? Next, let us have here the theoretical probability. A spinner divided into 4 equal portions and numbered 1 to 4 was spun. Okay, probability of having even is 2 out of 4. So, probability of 4 is 1 out of 4. Okay, so decimal and percent is given. And then, we have here the numbers 1 to 4 and the occurrences. So, we have the results here. So, the probability of getting 4 is 14 out of 50 or 7 over 25 or 0.28 and 28%. Okay, so as you have seen, probability of 4 in theoretical probability is different from the probability of 4 under experimental probability because it is an actual experiment. Okay? And also, if you have the even. Okay? So, as you have seen, we have probability of even is 25. Because we have 2, okay, is 11, and 4 is 14. So, that is 25. You will just add. And then, reduce to lowest term. So, 1/2 or 0.5 and 50%. Okay, question? Okay, so next, determine whether the experimental or theoretical probabilities used in each of the following. So, we have number 1, Cyril and Alisa played the Pinoy game 20 times. Cyril won 12 times. The probability that Alisa will lose the next game is 8 out of 20 or 0.4. So, what kind of probability is this? Correct. We have experimental because they have played the said game. Next, the probability getting a sum of 8 in throwing a pair of dice is 5 out of 36. What kind of probability is this? Okay, we have theoretical. So, even without playing the game or throwing the dice, so you can have the result. Next, the probability of choosing a senior from 25 seniors and 25 juniors is 1/2. Okay? What type of probability is this? That's correct. We have theoretical probability. Next, Anita surveyed 200 families in the barangay and recorded the number of children in each family. The survey results show that 110 families had 2 children and 90 families had more than 2 children. The probability that the number of families with 2 children is 110 out of 200. Okay? So what type of probability is this? Correct. We have the experimental probability because we have performed surveyed here or survey. Next, Bernadette tossed a coin 150 times and got 81 heads and 69 tails. The probability of getting a head is 81 out of 150 or 0.54. What type of probability is this? That's correct. We have experimental probability because you have tossed the coin 150 times. Okay? So, let's now have the third objective, solve probability events. Okay? So, there are 4 marbles, 5 red marbles, 1 green marble, and 2 black marbles in a box. Suppose you select 1 marble at a random. Okay? Or at random. What is the probability that the marble chosen is blue? That's correct. We have 1 out of 3 because you have 4 over 12. And 4 over 12, when reduced to lowest term, is 1/3. Next, what is the probability that the marble is chosen is red? We have 5 out of 12. Again, take note that you will just add first all the number of balls. Okay, so that's why we have the sample space 12. Next, number 3. What is the probability that the marble chosen is green? Okay, correct. We have 1 over 12. Number 4. How about black? Next, okay. So we have here, yes, 2 over 12 or 1 out of 6. Next, what is the probability that the marble chosen is not green? Yes, we have 11 out of 12. So you will just add the 3. Since we have 1 green, so you will just add 4, 5, and 2. Okay? So that's why we have 11 out of 12. Question? Next, determine the experimental probability of the following. Some rolled a number cube 50 times. A 3 appeared 10 times. Find the probability of getting 3. Okay? So we have here, okay, so we have 10 out of 50 or correct. Next, a coin is tossed 60 times. 27 times had appeared. Find the probability of getting heads. Yes, we have 27 out of 60. Reduced to lowest term is 9 over 20. Okay. Next, the Christian Dane drew a random set of cards from a well-shuffled deck of 52 playing cards. He recorded the suit cards that he picked. Results are shown in the table below. So for club, we have 8, spade 13, heart 7, diamond 4. So find the probability of selecting a spade. Okay, so we have 13 out of 52. So we have 1 out of 4 or 1 over 4. Next, a diamond. We have 4 over 52. Okay, so when reduced to lowest term, so we have 1 over 13. Yes, correct. Now, letter C, probability of selecting red card. Okay, red card is from the heart and diamond. So 7 plus 4 is 11 out of 52. Okay, so any question? Okay, so if you don't have, so that's all for this day about the theoretical probability and experimental probability.